Hello everybody and welcome to another Infinet Wireless webinar. My name is Radu Horoiu, Professional Service Engineer at Infinet Wireless, and today we are going to talk about link diagnostics for the InfiLINK 2x2 and InfiMAN 2x2 product families. The session will last for about 20 to 30 minutes. It will be recorded, and as always we will have a Q&A session in the end, but if you have any questions during the session, please write them down in the chat section at any time. My colleague Alexander Kozlenko from our support team is also here to help me with the questions in the chat section as well. Right, so for today I have prepared a link that has some performance issues, and I will explain to you what is wrong and what you can do to fix or prevent these issues. We will review the antenna alignment, the radio scanner, the instant DFS and the spectrum analyzer tools. And we will also look at the main parameters that give you an indication about the health of your wireless link. Now, one of the first things that you must consider when analyzing a radio link with problems is the obstacles that you might have between your devices. The situation that we are going to look at today is probably familiar to most of you that have used our units in the past, or similar units from other manufacturers. So you go and install your units in the field, and then you realize that the parameters of your link are very different from the ones calculated previously using a radio planning tool like InfiPlanner, for example. And you need to investigate why does this happen, why do you have these problems. So again, as I said earlier, first you have to look for obstacles between your devices, because most of the planning tools, including InfiPlanner, cannot take all the obstacles into account. They don't have information about all the buildings or trees or other obstacles like this that might block the path, the Fresnel zone between your devices. It's virtually impossible for InfiPlanner to take all these obstacles into account, so it is highly recommended to go to the field and perform a site survey prior to the installation. And even after that, if you have installed a link and in the beginning everything is fine, but after a while you notice some drops in performance, it can be because of some mobile obstacles that are blocking the path between your devices only for a short period of time. For example, like in the case of a building crane that passes in front of your devices and blocks the path between them. In case you have, for example, a fixed obstacle that blocks only a part of the Fresnel zone, and you are in the so-called near line of sight situation, the problem might be solvable on a short term by increasing the output power, but on the long term you will still have to go on site and move your devices. So if the weather is good, if you don't have a lot of rain, fog, snow, ice, stuff like that, and there are no other obstacles between your devices, then you must check the antenna alignment. And for this purpose we have the antenna alignment tool built in the web interface of our R5000 devices. So you simply go and click on the link that you have already established and check antenna alignment tool, then hit OK. And here you have multiple parameters. I'm not going to give you many details about them. You have the links that I gave you in the beginning in the chat section. You can go there and access those links and find all the details about the antenna alignment tool. And I also gave you the link for our YouTube channel, and there you will find many more interesting videos on many topics. So now I will only focus on the most important parameters from the antenna alignment tool, and I will bring up a table on the screen, a table that shows the recommended parameters, the recommended parameter values for these main parameters in the antenna alignment tool. So first of all, we have the RSSI, the received signal strength indicator, which must be between -40 and -60 dBm. If it is less than -60, this could mean that the link has been created using the side lobe of one of the antennas, and in that case you should change the azimuth or tilt of the antenna to make sure that the link is created using the main lobe. Next, we have the CINR, which stands for carrier to interference plus noise ratio. In an ideal situation, it should be equal or greater than 28 dB. The next important parameter is the crosstalk, which shows the amount of influence that the horizontal and vertical polarizations have on each other. Ideally, it should be less than -20 dB. And the EVM is another very important parameter. It stands for error vector magnitude, and it shows how far are the real constellation points from the ideal ones in the modulation scheme. And it should be less than -21 decibels. And you should also pay attention to the graphical indicators as well, these green bars that you can see over here. Ideally, the top of the green bars should be as close as possible to the center of the black areas. You can easily track the changes in parameters here using these bars as well. In my case, you can see that the alignment is far from ideal, but let's assume that this is the maximum that I could achieve in practice, and we will move on to the next troubleshooting techniques. Right, so I will close the antenna alignment tool, get rid of the table. If you have made sure that you have no obstacles between your devices, the antenna alignment is as good as possible, then let's see what else you can do before submitting a request to our support team. So if we consider the situation when at the moment of the installation you had a very good link with high throughput, the parameters were all optimal, but at some point after that the performance has dropped. It is very useful to know exactly when did the problem happen and for how long. So for this purpose we have the statistics graphs tool. Again, you click on the link, choose statistics graphs, then open it, and here you have multiple graphs for multiple parameters like retries, bitrate, load, CPU load, and so on. And if we zoom in, you will see exactly the time and duration for an increase in retries, for example, or a drop in bitrate. So this information can be very helpful, especially in situations when you have a mobile object that temporarily blocks the path between your devices. Right, so now we will look in the link statistics section. First of all, the ATPC and the auto bitrate should be on, and these must be configured in the link settings section. So here you have the checkbox for ATPC for automatic power and the one for bitrate, so these should be always checked. And right now, as you can see, the link looks quite good. We have decent capacity, so 51 megabits per second in one direction and 25 in the other. But I have to give you another detail about the setup. I have a second link which is installed alongside this one that operates using the same frequency, and I will use that link to generate some interference and see how this influences the main link. So I will go to master 2, and here I will generate some traffic using the performance test tool. So I'll click on the link, choose performance test, And since we are here, I will tell you a bit about the performance test tool as well. In the polling based firmware, or mint firmware like we also call it, you can perform tests for every available modulation, as you can see here. But in the TDMA firmware that I'm using for the main link, here you can only perform the test at the maximum modulation, but you can do the test multiple times, up to 8 times, so 8 rounds. You can select them here. Also, if you check loop back, the test will be performed in both directions, so both uplink and downlink traffic will be generated at the same time. Now I will run the test, and after it is finished, you will see that some green bars will appear indicating the throughput, the maximum throughput for each modulation, and the red part of those bars will indicate the percentage of retries. Now if we go back to the first link, we can already see in the interface statistics section that the number of errors is incremented. I will reset the counters to show you how the errors pile up here. But in a real scenario, it's not recommended to reset the counters unless you really know what you are doing, because otherwise the diagnostic process could be much more complicated when you submit the request to our support team. For more information about the errors and drops, we have the error drops and SNR statistics tool. So you click on the RF50 interface and then choose the tool. And here we can see that the retries are quite high at around 8%, and we have a lot of errors as well. Right, now let's look at the rest of the parameters that we have here in the link statistics section. And one of the most important ones is the TX and the RX capacity that I also showed you earlier. Right now you can see that the capacity has dropped a lot, almost to zero, from more than 75 megabits per second aggregated. Now we have less than 10 because of the interference from the other link. Other parameters that we have here, SNR, which stands for signal to noise ratio. If it is too low, you can increase the output power or change the frequency to a clearer channel where you have less noise. The level is an abstract parameter that indicates the fading margin for the current modulation. It should be more than 10 dB, and the difference between RX and TX should be less than 5 decibels. Then we have the bitrate, which is one of the most important parameters because the bitrate is directly linked to the maximum capacity of your wireless connection. Besides the quality of the link, the bitrate also depends on the MIMO configuration and on the bandwidth as well that you have selected here in the link settings section. So now I have 20 megahertz and channel type dual, so my unit is operating in the MIMO mode. But because of the interference, I'm now operating with minimum modulation, so I only have 13 megabits per second bitrate in each direction. Then we have the retries, which are also very important. This is a very important parameter. Ideally, the number of retries should be 0, just like the errors. So in an ideal case, the errors and retries should be 0, but you can live with an amount of retries up to 5 or even 10% in some situations, but that will not be a very good link that you can rely on. So ideally, it should be less than 5% or even 0. Also, here another important thing, the RSSI parameter, the values for the RSSI could at some point could have some asterisk symbols near them, and in that situation, it means that you have a big imbalance, a big difference between the horizontal and vertical polarizations. And this problem can have multiple causes, but most likely it's a bad connection or a damaged RF cable. In some extreme cases, it might indicate a hardware problem as well, so a problem with the radio. But in that case, there should also be a problem with the transmit power as well. About the situation when you have ATPC on and the transmit power is very high, it can mean that you have an interference and also a misalignment between your devices, and this can be a big problem in some situations, and the transmit power cannot be correctly set by the master unit, so the ATPC cannot work correctly. Right, so now we will move on to the radio scanner tool, which is also a very important tool when performing diagnostics on your links. Again, you click on the RF50 interface, go to radio scanner, and here you will see besides the bandwidth and frequency that you have configured for your link, the total number of packets, CRC errors, and pulses. This parameter, the pulses parameter, is very important because it gives a good indication of the amount of interference that you have on your link. As you can see, in my case, I have a lot of pulses. In the pulses field, you can see the total number, the average level of the pulses, and the average pulses per second. When the average pulses per second exceed 150, then the field lights up in red, so you know that you have a serious interference issue. Also, below the pulses field, you will have a list of the devices that generate the interference. In some situations, the device might not be able to decode correctly the information about the devices that cause the pulses, but if the interferers are Infinet units, you might get their MAC address, for example, or even if they are not Infinet but use the 802.11 standard for transmission, the Infinet unit could decode their MAC address. So this could be helpful when you are trying to find an interferer. And also, if they have as a type a capital N, it means they are neighbors, they are connected. So right now my master unit only sees the slave with which it is directly connected. And also, if there's a lowercase n, it means that it's a known node from the Mint network. And if you only see a dash, it means that it's an unknown source and the unit cannot decode the information about the foreign device that generates the pulses. Now, in order to reduce the effect of these pulses, you can use the RX attenuation parameter in the link settings section, and you can use it to increase the threshold for the noise, and then the unit will consider those pulses as noise and it will ignore them. So yeah, the RX attenuation parameter can be used to avoid the so-called capture effect that sometimes affects the wireless devices. The capture effect means that a foreign signal can be mistaken, if it has the same frequency, it can be mistaken for the useful signal of the unit. Right, so now we know that we have a powerful interference, but I have one more thing to show you, just a second. Moving back to Master 2, we see that the performance test has finished, and here you can see the throughput on each modulation and also the red bars that indicate the percentage of retries. Now I will run the test again, and when I run the test, you will see that the green indicator, the link quality indicator, will turn to red, as you can see now. This means that the retries are very high, and that's why this indicator turns to red, to show you that something is wrong with this link. Now, as I was saying, the interference is high. We know from the radio scanner that we have a high interference on this link, and we have two possibilities, two options to further analyze the interference on the whole supported frequency spectrum of the unit. And the first method is the spectrum analyzer, which you can find in the main menu. And here you have some parameters that you must configure. So first of all, start and stop frequency. You can scan the entire supported frequency band, but I will limit the scan area to a smaller portion, to do it faster. Another important thing, you should use combined mode. So it is recommended to use the combined mode because that way you will get a combined interference picture. So you will see the interference from the local side and the remote side on the same picture, and you will avoid getting the signal of the remote unit as an interference in this picture. Right, so I will start the spectrum analyzer test, and you can already see that on the exact frequency that this link is operating, there is a high amount of interference coming from the second link. Now, obviously in this case we know that one of our links is causing this problem, but in real life it could be a foreign device, and in this case what can you do? You have two possibilities. If you use the unlicensed band, the best thing to do is simply move to another frequency, another channel that is free. But if you have a license, if you have a licensed band and you have paid for this frequency, then you might need to file a complaint to your local authorities that someone is using your frequency without authorization. Or you can search for the interferer yourself if you, I don't know, maybe you forgot about some old devices that you have installed in the past, and they might cause this interference. Right, now moving back, the second method of not only measuring but also avoiding the interference is the instant DFS. Now, before talking about instant DFS, I must say a few words about the regular DFS, which stands for dynamic frequency selection. It's a standard mechanism which all the devices in the 5 GHz non-licensed spectrum must have. It is implemented in order to avoid interfering with radar signals that also operate in the 5 GHz band. So basically DFS works like this. When radar is detected, transmission must be stopped on the current channel for about 30 minutes, and then a channel availability check must be performed, and the master unit will scan the spectrum for another free channel. And obviously this has a big disadvantage because during the channel availability check the link will be down, so you will have a lot of downtime with regular DFS when radar is detected. But we have a better option that's called instant DFS, and this works by having inside the Infinet units a second radio board that is used to permanently scan the spectrum and have a very detailed map of the interference in the whole frequency spectrum, and always choosing the best channel instantly, so you have no downtime at all. Because this is a physical option, you cannot upgrade your units later by license to instant DFS, for example. So you have to know before ordering the devices if you want or need instant DFS or not. You cannot do it afterwards. You have to replace the whole unit if you need instant DFS after you install the link. Right, now instant DFS, if you have selected DFS only or DFS with radar detection in the link settings, then instant DFS is enabled by default if it is supported by the unit. There is no separate setting for instant DFS. Now regarding the regular DFS, you have three options: DFS only, DFS off, and DFS with radar detection. On this unit I only have DFS off and DFS only. It's a very old unit and it doesn't have all the options, but I will show you the third option on Master 2. Just a second. Yes, if I go to basic settings, link settings on Master 2, here you can see that the DFS with radar detection option is selected, and I cannot turn it off. This is usually the case when we sell our units into countries where DFS is mandatory. So regarding the other two options, DFS only means that the interference will be calculated and the best channel will be selected once a day, but radar detection will not be performed. And DFS off turns off the DFS. It's not recommended to use it. If you have selected DFS only, then in order to make DFS work, you have to also select automatic frequency. Until now I had a fixed frequency because I wanted to show you how the interference situation looks like. But now I will select auto, and the slave units must have automatic frequency as well. And if I click apply, then the instant DFS will be enabled for this unit. So now if I go to the DFS section in the main menu, you can see here that instant DFS is enabled, and that we already have another channel which is cleared. So the master unit has scanned the number of channels that I have selected here. I don't have the whole frequency spectrum, I only have a small number of channels to make the scan faster. And in the legend you can see that the channel marked with green is the channel in use, and the yellow bars in the other channels indicate the interference level. So you can see that on the frequency that I had before, the interference is very, very high. Basically that channel is unusable. And now if I go back to device status, you can see that we have another operating frequency, and if I open the radio scanner, now we have basically 0 pulses. We don't have any interference. Right, so this brings us to the end of the session. Now if you have any questions, please write them down in the chat section. Me and my colleague Alexander will be more than happy to answer them. Thank you. Right, so the first question from Nick. To me and Alexander, do you both prefer TDMA over polling? Now, it obviously depends on the situation. In this case, the TDMA was the better option for our main link. But in point-to-multipoint networks where you have a lot of CPEs, then the polling-based firmware is a better option. The next question, does IDFS only occur at the master? What happens at the slave? Yes, in our current product lineup, only the master unit decides when to switch the frequency. So only the master uses instant DFS. The slave unit can scan for the interference, and it informs the master, so it does some scanning as well if it has the IDFS option, the second radio board, but it doesn't decide whether to change the frequency or not. So only the master does this. So I hope this is clear. The slave can have instant DFS, but it cannot decide whether to change the frequency or not. Only the master does that. Next question about a situation where you have the radios going offline for 30 minutes. Yes, you might need instant DFS in this situation because most probably you have some radar detected, and that's why you have those 30 minutes of downtime. Next question, can firmware updates affect the traffic or the good quality of the connection on the links? Usually if you upgrade to a stable version and not to a beta version, you should have no problems at all, but you must remember to upgrade both ends of the link or all the devices in the point-to-multipoint network, because otherwise if you have a very old firmware on a device and a newer one on the other one, you might have some problems because there might be different features on the different firmware types. Next question, if you have a link where you have bad quality and you tried everything that was presented in this video and nothing worked, then it's a good idea to send the diagnostic cards to our support team, and they will be able to perform a more thorough analysis for your specific situation. Next question, I have tried to upgrade from TDMA to Mint and I cannot upgrade. Why? You have to follow a procedure. I will search for a screencast on this topic on our IW Academy. I will search for it and give you the link in the chat right now. Right, so Mackie, you have the link for the screencast on how to upgrade from Mint to TDMA. Next question, when do we know that the device needs a new firmware? You can see in the maintenance section, you can see the current firmware that you have, and you will also get a message that the new firmware is available for download, or you can just click the check latest release button, and we always recommend upgrading to the latest version. So it is a good idea to constantly go to your devices and check for the latest release. If you have the possibility to, if you don't have too many devices, it's a good idea to go and check for a new firmware from time to time. Next question, is there any way we can upgrade and get instant DFS? As I mentioned during the webinar, the only way is to purchase a new unit that has the second radio board inside that's specifically designed for instant DFS. You cannot upgrade to instant DFS by license. Right, so again a question from James about a couple of links that were damaged in the past. Yeah, so only the support team can tell you exactly what the problem was, what the physical problem was when you had to replace the units. Maybe they were damaged by other high power devices in your area. There can be many causes for this. Right, another question. If you use polling with QoS mode and without QoS mode. If you have high priority traffic passing through your link, like voice or video, live video or something like that, it's a good idea to enable polling with QoS, because this will take into account the priority for each stream of data as well. When the master, the base station, polls the CPEs to see what data they have to transmit, it will take into account what type of data, what is the priority for each data stream that each CPE has to transmit. So if you have high priority data, it's a good idea to enable polling with QoS. Next question, what happens if you choose instant DFS and the spectrum is full? Maybe try the QMXB that has a beamforming antenna, and it can use a narrower beam to connect to the CPEs in case of a point to multi-point connection, but in case of point to point, maybe use some higher gain antennas. This could help in some situations because the beam will be more focused, and this way you could avoid interference coming from other directions. Right, next question. What can you do when you have too much signal, like received signal level of -10 dBm due to very short range, so very short link? So first of all, you need to check to see if you have the lowest possible output power. Then maybe choose some lower gain antennas, and in some extreme situations it might be a good idea to use external antennas and use some RF attenuators between the unit itself and the external antenna. Next question about the maximum capacity. Alexander has already answered this question. So for the point-to-point links, the R5000 Pro devices, the maximum capacity is 280 megabits per second, but we also have point-to-point links with higher capacity from the XG family, and those go up to 1 gigabit per second. So the next question, what is the minimum SNR to get during the installation for the slave CPE? As Alexander said, it's at least 5 or 6 decibels. Next question, please explain again how to decrease the pulses per second for the link. I will go to basic settings, link settings again, and yeah, you do it by using this RX attenuation parameter. So if your pulses, for example, if your pulses have a level of around -65, let's say, and the noise level is somewhere around -90 dBm, then you need to increase the noise threshold from -90 to -65 in order to make the unit ignore the pulses that have -65. So in this case you will use an attenuation of 25 dB, and That's how you will basically order the unit to ignore the signals that are 25 dB higher than the noise threshold. So in a usual situation when you have RX attenuation 0, then the unit only ignores signals that are lower than the noise level. If you increase that level, then you ignore more signals, hopefully including the pulses as well. Of course, this this implies that your useful signal, your useful RSSI must be higher than the pulses, must be more powerful. Otherwise, you cannot use the RX attenuation parameter to get rid of the pulses. Next question, what is the maximum distance with external antennas for the XG1000 over the sea? We have a link, just a second, it was one of our previous webinars. We have a real installation over the sea somewhere in Zanzibar. And here, yeah, XG1000 with 38 dB external antennas, around 60 kilometers, and the capacity was 682 megabits per second. So you can go much more than 60 kilometers, maybe 100 or something like that, but over the sea, you should be careful about the reflections. So it might happen that the reflected signals from the surface of the sea could affect the quality of the link. Next question, can the base station or CPE interfere with 5 gigahertz homebox internet? Yes, of course. If they use the same frequency, they can interfere with each other. So if they are closer than a few meters, I don't know, closer than 5-10 meters, you have to be careful, because by chance, if they use the exact same channel as I showed during the webinar, the interference will be very high, and there will be problems with both the homebox and the Infinet devices. Yes, regarding this topic, Nick has said that the indoor Wi-Fi and the outdoor fixed links have different ranges, but our devices support the whole 5 gigahertz range. So if you did not limit manually the frequencies that our devices can use, then they can use the indoor frequencies as well, and some interference might appear. Next question, why is there always an issue when the link is installed over the sea? As I mentioned earlier, there can be reflections. So the reflected signal from the sea level can interfere with the direct signal, and they can combine destructively, so the reflected signal will affect the direct one. And this situation can be avoided by installing some kind of obstacle, or using a natural obstacle like a cliff, for example, right before one of the units, in order to block the reflected signal. Next question, it is possible to upgrade the firmware on one CPE, and the changes can affect the other CPEs on the same network? As Alexander said, usually no, firmware on one CPE should not affect the others. Next question, the constructive and destructive combining of the direct and reflected signals also happens in WiMAX. I think it can happen, yes. All wireless links over the sea can be affected by reflections. Next question, can the use of unlicensed antennas affect the capacity of an Infinet device? Of course, yes, because in the unlicensed bands, you might have a lot of interference, and in a heavily interfered environment, obviously you will not be able to achieve the maximum capacity of that link. So when you upgrade the CPE, is there any command to upgrade the other CPEs remotely at once? Yes, it's the, just a second, it's the over-the-air option. Here in the maintenance section, if you upload the firmware file here and then check over the air, then this unit will send the firmware to all other units in the Mint area that are compatible with that firmware file that you have uploaded here. So you just check over the air, and then you also have the option to send only to the neighbors or to all other devices in the same Mint network. And then click upload and the firmware will be sent to all the devices. Right, so another question regarding the space diversity. Of course, you can use space diversity with our devices as well. And also frequency diversity with guard intervals, you can use them both at the same time. Next question, how many CPEs does a base station support? Yes, as Alexander said, we have examples of more than 150 up to 168 CPEs connected to only one sector. But in this case, obviously the capacity will be quite low for each CPE. So the 240 megabits per second of the sector will be split among these more than 150 CPEs. And also the latency will increase, obviously. If you use polling, you might get better results than with TDMA, because if you use TDMA with 168 CPEs in a sector, then the guard intervals will be so high that they will eat up much of the capacity, and this will lead to high delays. But with polling, if only a few CPEs need to transmit some data at a certain moment, then only they will be allowed to occupy the bandwidth, so the resources will be utilized more efficiently. Right, so next question, are there any units working with SFP now? So if you mean units that support SFP connection, yes, we have the XGs in our current lineup. They are the only devices that support SFP. And we don't have proprietary SFP modules, so you can use any third-party SFPs, and they will work with the XGs. Another question from Nick. If you have H08 base station that has 4 CPEs, H11 connected to it, you can upgrade, yes, you can upgrade all CPEs at the same time, of course, by using the over-the-air option on the base station. So you upload the H11 version on the base station, then check over the air, then click upload, and the firmware will be sent only to those devices that are compatible with the firmware. So the firmware doesn't have to be compatible with the local unit that you are connected to. So it will be sent only to those other devices in the Mint network that are compatible with that firmware. Next question, is there any way to configure bandwidth manager on the base station for the customers that are connected for a dedicated bandwidth client? Yes, of course, we can do all sorts of traffic shaping mechanism and filtering. I will show you a bit here in the basic settings section. You have the traffic shaping menu, and here you can create classes, channels, and then limit the amount of traffic in each channel or class. And in every channel you can put different types of traffic. You can filter by VLAN, by IP, network, and so on, even protocol. Every criteria that you can imagine you can use to filter the traffic, and then limit the amount of throughput for each channel. Next question, what about the OMX? Are they working with SFP? No, the OMX units do not have an SFP port, so only the XG devices. Right, so Sami, if you need a link, an XG1000 link with at least 700 megabits per second of capacity at 11 kilometers, and you also have high interference, yes, my colleagues at support will be able to help you with this request, because you have to perform a thorough spectrum analysis there in order to see whether you will be able to achieve that capacity or not. It depends on the amount of interference. And you will also have to use some high gain antennas with really narrow beams, and that's how you might be able to trick the interference a bit. And maybe you will be able to achieve the capacity that you need, because in that situation that I showed you earlier, the real installation that we had in Zanzibar. The link was installed over the sea, and there was a lot of interference, and still they got almost 700 megabits per second. So I think it's doable for you. And in that case, the distance was 60 kilometers. You only have 11 kilometers. Right, so if there are no more questions, I think it's time to end. It's been a very long session. I'm really glad that so many of you have joined and have asked questions. It was a really fruitful session. So thank you all once again. Thank you, Alexander, Nick, and all of you that have joined, and see you next time. Goodbye.